The latest study is one of the biggest probably was conducted by the Justin Sonnenberg's couple, the Sonnenberg's couple, but led by Justin Sonnenberg from California University in the States, where they basically looked into people from the hunter-gatherers tribe. They took their gut microbiota using their stool, and they compared it to the stool from people from California. And then they found that people from the hunter-gatherers, they had literally 723 more bacterial strains that were never discovered in people living in California. Somehow these microbes went extinct already. They don't already exist. And some people say that, and some scientists actually say that we've probably lost more than 50% of our microbial diversity compared to people 100 or 150 years ago. The truth is that our mode of living today is filled with a lot of processed food. One of the let's say the factors that actually influence negatively our microbial diversity. We eat less and less and less fibers, so we just eat more processed food and so on. And more importantly, we do abuse more medication today than we did 50, 60 years ago. So there are many countries where antibiotics aren't even under prescription. You literally can take them anytime. So this had led, in my opinion, that some and many microbes went extinct, which actually correlates very well with an increase of many chronic diseases. Very diverse. So we have the facial microbiome, which is mostly dominated by one bacterium or genus or genera called Cutibacterium acnes. And by the way, it is the same bacteria that causes acne. So Cutibacterium acnes was formerly known as Propionibacterium acnes. It does cause acne. However, within this same genera, we do know there are other species. A species is like, it's like me. My name is Amine Zorgani. But if you want to create a species of me, you would say Amine Zorgani 003, right? So that is a species of me, so like more specific. So Cutibacterium acnes it is the genera, however, or the species, but it has many different strains that actually differentiate each other from a pathogenicity perspective. So we're mostly dominated with one species or clade called A1. However, there are many other ones that are actually known to not cause acne, but rather they can even fix or treat acne. And the company I was working with, we were working exactly on this. So we're trying to isolate Cutibacterium acnes from healthy people, characterize that bacterium, and then make it to become a probiotic for topical applications to literally treat acne. So sometimes it can feel controversial because people would say, listen, Cutibacterium acnes isn't it the bacteria that actually cause acne? And then you're trying to give it to me to cure acne. I said, yeah, because not all microbes are the same. So we differentiate the bacteria on the strain level, and this is the difference. We have other bacteria actually on the face that actually can be beneficial in terms of diversity and improving the function of the cells. The skin has different layers, so you have the dermis and many other layers. But all these actually have what we call the skin barrier function. So if your skin barrier is damaged, you start losing water, which is the transepidermal water you're losing, and that actually start giving you wrinkles and dryness of the skin and so. What we try to do by modulating the skin microbiota is improving the skin barrier function, similar to the gut, where we say the gut barrier function, or similar to the brain, the blood-brain barrier function. In the skin, we say the skin barrier function. So improving this can improve or reduce this transepidermal water loss, like the loss of water throughout the skin, and keeping your skin hydrated, giving it this brightness and reducing the wrinkles. And most of the approaches currently actually do use that. There are other bacteria that are involved, like Staphylococcus epidermidis and so. However, we don't have only bacteria on skin. of the face, we have bacteria in the armpit, which basically can cause odor or malodor. So some people like the Dr. Armpit, Chris Calloward, he's actually working specifically on this, isolating or
microbiome of vagina. I mean, it's I believe it's a different perspective because very often doctors will go for hormonal therapies, and when I saw that there is a actually distinctive connection between actually fertility and the microbiome of vagina, I think it's a very interesting subject matter. And just if you would just say something, what do you know about this? It will be very interesting to hear, because I don't think that many people even aware of such a thing.
Absolutely, and I think so. If you speak about social media, so there are a lot of also misconception. So today, I've seen many let's say misleading posts from either TikTok or whatever, Instagram. So
yes,
people claiming that there are some magic pills. Like
yes.
there are some like magic probiotic pills that can make you pregnant or improve your vaginal microbiota and what so. But let's just put the E's on the letter, as we say. So number one, you need to understand what is a vaginal microbiota. Number two, how you can positively influence that vaginal microbiota, and whether going through the gut can actually make any sense or not. Because taking a food supplement that actually goes into your gut, would that really reach the vagina to improve that? And number three, which is the topic that most women actually and men try to improve and find solution for, is infertility and pregnancy. So can this actually work? So let's start with number one. What is the vaginal microbiota and what is its importance? So we do know that dysbiosis in the gut is actually a disbalance between the different microbes. So they have an increase of some pathogenic bacteria and a reduction in some beneficial bacteria. And obviously that's reduced into the diversity. So a reduction in diversity in the gut microbiota is considered as dysbiosis. However, in the case of the vaginal microbiota, a reduction in diversity is a good sign, because the vaginal microbiota is mostly dominated with one bacterial genera called Lactobacillus, and there are different species of Lactobacillus like Lactobacillus jensenii, Iners, and many others, right? And these are the ones that basically are known to have an association with a healthy vaginal microbiota or a healthy vaginal health in general. An increase of certain other pathogens like Escherichia coli or Staphylococcus or Gardnerella, which is one of the known also to cause bacterial vaginosis, is a sign of an increased diversity in the vagina, and it's usually associated with symptoms. It doesn't mean that if you have Gardnerella now in your vaginal test, microbiota test, that you are specifically sick or you have a bacterial vaginosis, because there are some women, they do have Gardnerella in very high quantities, more than 50% of abundance, but they don't have any symptoms. This may be something to watch, because maybe if they would like to get pregnant, maybe it could be an issue for them. However, the science shows today that one very excellent example that was published in the Lancet, there is one woman that she had 3 pregnancy losses. She didn't, she had miscarriages. She had a very severe bacterial vaginosis. She had 31 years old. And it was published in Lancet. I actually interviewed the professor, Henriette, that basically did this assay. It's called Patient Zero. And then what they did, they went and they found a healthy woman that had a healthy vaginal microbiota. They did a microbiota test on her vagina. And they found the usual composition with the different lactobacillus strains present in her vagina. So, and then they transplanted the vaginal microbiota from this woman, the healthy one, to the woman that had 3 pregnancy losses and bacterial vaginosis. And after 5 months only, the woman became pregnant. Right? I mean, there is no need to go into the details. What the
I didn't
concept
see
of
this, but that's very fascinating. Mm-hmm.
So what this means, this is one of the straightforward approaches that basically shows that transplanting, if you want to give them a chance to survive, you better off give them the food they need. The best way of doing it is to eat fibers, eat plant-based food, right? So ideally, number one, you should never take your probiotics after food or at midday. You should take it early in the morning before you take anything. Your stomach is in a neutral pH. It's not that full. So if you take a pill of a probiotic, it can get quickly to your intestine, so reducing the chances of it dying in the stomach. So that's one. Number two, eat at what we call the rainbow food, fruits and vegetables. Literally, colored fruits and vegetables are filled with fibers, and some of them do contain prebiotics. The prebiotics are the food of the probiotics. If a probiotic have the food, which is the prebiotic, they have a good chance to produce what we call a postbiotic. The postbiotic is the molecules, the metabolites that the bacteria produce for us to function better. So to come to your conclusion, if we would like to improve the engraftment, which is how the bacteria stick to the destination and the host and stay there, we have to give them the food to do so. However, if we are talking about transplantation, there is a better chance if someone from France transplant to someone from France that these people do match. It's like an organ transplant. We're transplanting microbes, right? Probably the chances will be less.